So in this lecture, we'll discuss the topic of edge detection. So the question is, what is an edge? So intuitively speaking, an edge is a set of connected pixels that lie on a boundary between two different regions in an image. And thus, to be able to detect an edge, we should be able to measure the gray level discontinuities or the color discontinuities in an image. So basically, edge detection essentially amounts to finding discontinuities in the intensity values if we are dealing with grayscale images, or discontinuities in the color values if we are dealing with color images. And thus, since in edge detection we deal with finding discontinuities, and thus edge detection methods are typically sensitive to noise. And this is the reason why before running an edge detection algorithm, we typically smooth out the images to remove some sort of noises or texture in images. And this is where the methods that we discussed in the previous lecture become very useful. For example, in the previous lecture, we discussed naive methods like the uniform filter, the Gaussian filter, the median filter, which were able to remove noise, but they cannot preserve the sharp transition in images. And then we covered some of the filters like bilateral filter and Covara filter, which were very efficiently able to clear out the noise in images, as well as clear out some of the texture in images if it was useless. And they were also able to preserve the edges or the sharp transition in images. And this is where the content that we covered in the previous lecture makes sense when we try to compute edges in images.